Well, thank you very much for coming, everybody. As you are probably aware, Gabby and I run a global online graduate certificate, graduate diploma, and master's degree in what we call the economics of sustainability. It's centered on modern monetary theory. And if I'm anything, I'm a modern monetary theory economist who spent my life training bankers. So I'm really a long way outside my lane this evening, but also ecological economics too. As Stephanie Kelton has said a number of times, learning MMT is like learning an instruction manual in terms of how the monetary system works and how it can be used. Ecological economics is vitally important because it should tell us what we ought to be trying to do, particularly at this stage in history, with the monetary system. If MMT, to use an inappropriate analogy, is the instruction manual for how a car works, then ecological economics should be telling us where we should be driving the car at the moment. Now, we have some brilliant ecological economists involved in our program. Our ecological economics subject was written by my dear friend, Phil Lawn. We have brilliant ecological economists teaching with us at the moment. We have Rigo Melgar from Vermont, and we have Colin Schneider from Austria teaching on the program, and either of them could do a talk like the one I'm going to do this evening much better than me. And the title you can see at the bottom of this slide, Sustainable Prosperity, what does it look like and how we're going? That's really a question that I'm going to be asking our students in the near future on the program and over the next couple of years. And you have to start off a conversation somewhere. So I have put together you might see it if you're an ecological economist, a childishly simple indicator, which, for want of something else to call it, we'll call it the Modern Money Lab Progress Indicator version 1.0, that they can discuss and improve upon, and that is simple enough. It's simple enough so that we should be quickly able to put some data together from published, easily available statistics for more than 100 countries, be able to update it over time and be able to integrate it with realistic but highly simplified macroeconomic models so that we can look at scenarios relating to policies and outcomes in the future. That's the idea anyway. So you've got to start somewhere, and there's no one else who's going to start the conversation off, so I'm going to start the conversation off. That's why it says version 1.0 on here, on these slides. The MMT basics, you may well know. This is me being in my lane. If you know anything about modern monetary theory, then you already know governments which issue a floating currency and don't have significant debts denominated in other currencies have more fiscal freedom of action than other governments do around the world. We call them full monetary sovereigns. The Australian government is a full monetary sovereign government. So is the US government. Although, strictly speaking, it doesn't have its own currency. I think it's fair to describe Germany's government as a full monetary sovereign. And the same thing, I think, you could say about China as well. I mention those countries because we're going to look at the Modern Money Lab Progress Indicator relating to those countries this evening. Monetary sovereign governments face real constraints. Of course they do. There are limits on the productive capacity of our economies, dependent on our labour skills, capital equipment, technology, our natural resources, and our institutional capacity. And over time, the most important constraints we face are our ecological ones, but there are no purely financial constraints. What I was saying last week, amongst other things, is that It is normal for monetary sovereign governments to run deficits on average around the world. They do every year. It's unusual for monetary sovereign governments to run budget surpluses. Usually they run deficits because if the rest of us are going to net save, if the non-government sector, the non-government part of the monetary system is going to be in surplus, then somebody's got to spend those dollars that we're saving, and those dollars are deficit spending by the monetary sovereign federal government. So monetary sovereign governments have a lot of fiscal flexibility. Now, how should they use that fiscal flexibility? How should they use the powers that they enjoy as a result of being currency issuers? They should act in the public interest. That's what we normally say, and that's the argument that's made in Stephanie Kelton's best-selling book, The Deficit Myth, and in the documentary movie that some of us have seen, Finding the Money. But what do we mean by in the public interest? It can't be growth for the sake of growth, particularly at this point in history. I put what you can see on the left-hand side of the slide, a picture of my book up on the screen, because just by chance, I think it's 6 years ago today, the book Economics for Sustainable Prosperity was published. I'm making no claims for it being a great book or anything, but I think it was the first MMT book to take sustainability seriously. So if it's important for anything, it's important for that, I suppose. If growth for growth's sake cannot be what we mean by managing our economies today and in the future in the public interest, then what do we mean by that phrase? We should be focusing, particularly in high-income countries, on what we mean by the word well-being and managing our economies to promote the well-being of the whole population, providing the social foundations of a good life for all. So meaningful indicators of our progress over time should take this into account. And of course, it's vitally important that we move back within our planetary boundaries very quickly as well. So sustainability has got to come into any indicator of the success or failure of our economic management over time as well. But how can we judge this? Well, it doesn't matter whether you're talking about Australia or whether you're talking about the US or whether you're talking about China or whether you're talking about virtually any country in the world. How things are judged at the moment is to look to see whether the economy is growing over time, how quickly it's growing. Perhaps when inflation has been relatively high recently, then the inflation statistics play a big part in the way people see the success or failure of governments. But basically, issues like carbon emissions, climate change, ecological issues generally, even inequality, are not seen as objectives for governments. They're seen as constraints. So if you're managing the Australian economy, you want to keep it growing, but you accept the need to set targets for carbon dioxide emissions in the future, and you accept that you just have to live within a situation where you've got to meet targets that you've set for yourself into the 2030s and beyond. You prefer those targets to be long-term so that the consequences of missing them, if you do, happen when you're not Prime Minister anymore. But basically, you're focusing on growing the economy. We want to see Australia's population grow. We want net migration to remain high if it's necessary to make the economy grow. If that's what we're focusing on, and the constraint of people having somewhere to live and infrastructure to support them, well, that's a constraint. It's not something which is usually at the centre of how you think about economic management. So you can see Australia's economy growing over time here. Real GDP at constant 2023 prices. What that means is the data here has been inflation adjusted, and earlier years figures have been increased so that they're estimates of what Australia's gross domestic product would have been, how big our measure of the economy would have been had we been looking at GDP in those previous years at today's price level. So this takes into account the growth in what we sometimes call our nominal GDP, the monetary value of our gross domestic product, but it also takes inflation into account too. You can see the dip in 2020. You can also see a dip in 2009. Well, officially, we didn't have that dread word, a recession, in 2009 because our real GDP didn't contract 2 quarters running. And that's how a recession has come to be defined in Australia and many other countries. But if you look at Australia's real GDP across the calendar year 2009, that's what we're looking at here, based on data from the World Bank. There was a dip in that year, but you can see the economy growing, and it's almost doubled in size between 2000 and 2023. That means it's grown at almost 3% per year, year after year after year. Keep that going for 250 years, and you have an economy 1,000 times as big as we've got at the moment. That's obviously not going to happen. It's a similar story when you're looking at the US, apart from the fact we're looking in US dollars, and the figures on the left-hand side have got a 0 after them because the US economy is many times bigger than the Australian one, of course. But once again, the success or failure of governments down the years depends on what's happening to real GDP. If real GDP falls just before a presidential election, as the first President Bush could have told you, then you're going to have much less chance of being re-elected than otherwise. This is what everyone focuses on. China, of course, and the figures this time are in yuan or renminbi, Chinese currency, but again adjusted for inflation. China's economy has grown faster for longer than any other major economy in history. And this is seen, and in some respects, this is, of course, genuinely the case because it has been instrumental in lifting millions of people out of poverty. This is seen as one of the great success stories of global economic history. But we shouldn't be judging, well, especially not in already rich countries, in Australia, in the US, in Germany, if I put Germany's chart up. We shouldn't be judging the success or otherwise of economic policies in the years to come based purely on the scale of our economic activity, real GDP. To state the obvious, this ignores population. Now, I know some people like to talk a lot about sustainable population. I'm going to be talking a little bit more about the distribution of income this evening, because although if the global population was lower than it is at the moment, we would be placing less of a strain on our planetary resources. The same thing would be true if we had a less uneven distribution of income. And the distribution of income is much easier to act upon over time than the size of the global population. GDP also, as is often said, doesn't include unpaid labor, including unpaid labor in the household, caring labor at home, which ought to be included in any indicator of human well-being. As we've said many times before, it makes no distinctions between goods and bads. Trees play no role in gross domestic product until you chop them down, and includes purely defensive expenditures. So spending on tobacco is a bad. Well, that's included in GDP. In most countries, spending on illegal narcotics, at least an estimate of it, is included in GDP. If there's an ecological disaster because of an oil tanker sinking and pollution having to be cleared up, then that's included in GDP. If you have a much bigger prison system than before, so there's more spending on that, that's included in GDP. It's far from a measure of well-being, as Simon Kuznets, one of the pioneers of national income accounting, said back in the 1930s. That wasn't the original aim of the national income account anyway, but it is treated commonly as though it is a measure of well-being or economic success. It's a measure of the scale of our economic activity. Even then, it's not a perfect one for reasons I'm not going to go into now. most importantly of all, it ignores the ecological impact of economic activity. And that's something that shouldn't be the case in this decade. As Johan Rockström, in a documentary in which he was quoted 2 or 3 years ago, said, Johan Rockström, one of the people that developed the 9 planetary boundaries that are regularly discussed these days, including in Kate Raworth's book, Donut Economics, about 15 years ago. He said 3 or 4 years ago, what we do between 2020 and 2030 will be the decisive decade for humanity's future on Earth. We ought to have simple metrics of how successfully we are dealing with the problem of maintaining and improving people's quality of life without destroying our natural environment. Because looking after our home matters for everyone. This chart is a very important chart. It emphasizes the fact that our economic activity and our society, of course, sits within a finite planet, a finite biosphere, planet Earth, from which we extract renewable and non-renewable resources, which we process in order to provide us with goods and services which give us use value over time when we've consumed those goods and services, and indeed as part of the production process as well. We generate waste, including, of course, carbon dioxide and other greenhouse gases. So we take resources from the Earth, we generate waste, which the Earth then has to absorb, the Earth system has to absorb. Now, as long as we don't overwhelm natural systems, the Earth does a good job of processing our wastes for us. And of course, the activities which people often discuss under the heading of the circular economy are over time reducing our ecological activity for every dollar of goods and services that we produce and consume. But it remains the fact that the economy, as Herman Daly used to say, is a wholly owned subsidiary of our ecosystem, our biosphere, of planet Earth. Planet Earth has limited biocapacity. It's not an isolated system because it takes in solar energy and emits waste heat into our local environment, but that's virtually everything that gets into our planet and off it, forgetting about how many satellites for the moment. And this means if we're going to live sustainably, as Herman Daly used to say, we should not be using our non-renewable resources more quickly than we can develop renewable substitutes for them. We should not be using renewable resources more quickly than they can be renewed, which is why you shouldn't be chopping down all the old growth forests or catching all the fish in the sea. And we shouldn't be generating waste, including but not limited to carbon dioxide, at a rate which is above the rate at which our planet can safely assimilate them. So this should be central to any measure of sustainable prosperity. And although the rules for national accounting, the system of national accounts, which was originally published by the economists at the International Monetary Fund in 1953, and has, I think, 4 times since then been revised, the last time in 2008, where they produced a more than 700-page manual of how to go about calculating GDP, although they are at the moment preparing the next revision, which should come out next year, and where there will be some improvements to gross domestic product accounting. It's still not going to be the case that the environment is central to the national accounts, as of course it ought to be. Now, when you talk about gross domestic product not being vitally important when we think about well-being for high-income countries, my economics colleagues, particularly my neoclassical economics colleagues, generally counter by saying, well, There is a positive relationship across the complete range of GDP per person between both subjective and objective measures of well-being and GDP. So countries do benefit from having a higher gross domestic product per capita. What we've got on the chart on the left-hand side is from the Gallup poll, the mean answer, the average answer in countries to the question, if you had to scale your life satisfaction, how satisfied you are with your life between 0 and 10, what would your answer be at the moment? So it's highly subjective, but it is a question that the Gallup polling organization asks in more than 150 countries around the world. And it's true that if you put all 150 countries down on a chart for any year, you do get a logarithmic kind of curve, which you can draw through the data as a line of best fit. So yes, gross domestic product per person does matter for subjective well-being if we're talking about low or middle income countries, absolutely, as you would expect it to do. And the same thing is true if we're talking about objective measures of well-being as well, like life expectancy or crime rates, things like that. But this is no longer true if you separate out the richest countries. So I've taken the 35 highest income per capita countries in 2020 here. That's countries above Estonia as far as the data is concerned. And what the chart on the left-hand side is saying is that there's no statistical evidence of a relationship between subjective well-being and gross domestic product in the richest countries in that year. And you'll find the same result in any year for the richest countries, at least in any year in the recent past. And we'd get the same result, as I mentioned before, if we were talking about objective measures of well-being as well. However, I don't want to have a pointless fight with neoclassical economists. So in our measure of sustainable prosperity, we are going to include as an element within it real GDP per capita, but you could argue that maybe we shouldn't. A big element in our measure is going to be inequality. There are various measures of inequality. There are various databases relating to inequality. The most commonly used statistic for inequality that economists refer to is the Gini statistic for net income. Now, I don't want to talk about how it's calculated for the moment. It's not a perfect measure of inequality. It does take everybody into account. It has a value of 0 in a society where there's perfect equality, where everybody has the same net income. It has a value of 100 where there's perfect inequality, where one person, or let's say the top 1%, has all the income. So a higher Gini statistic means more inequality. And what you can see on the right-hand side here, which is also something which is true every year, is there's very strong statistical evidence that for a variety of reasons that we don't need to go into now, when you look at rich countries, and there's 34 as opposed to 35 because you don't have, there's not data on inequality for everyone necessarily. There must be one country that's missed out, forgotten which one here. Then you get a statistically significant relationship. Countries with lower levels of inequality have populations that are more satisfied with life. And actually, and we're not necessarily talking about cause and effect here, but we're talking about a correlation. And they score better on a variety of statistics, as I said, including things like life expectancy and crime rates and all sorts of things. So we ought to be focusing more on inequality. GDP then is far from a perfect measure of well-being. There are better alternatives. Indeed, there are over 100 alternatives out there, alternative approaches out there. Some of the best of which involve looking at a panel of data. Indeed, the Australian Commonwealth Government now publishes statistics under the heading of measuring what matters on a website for a range of a range of issues which are important to well-being and ecological sustainability. They just don't get talked about very much. You may be familiar with Kate Raworth's brilliant book, Donut Economics. In Donut Economics, of course, she defines a regenerative and distributive economy, or an economy located in the ring of her donut, in a safe and just space for humanity, as she calls it, with respect to an economy that provides everyone with the social foundations of a good quality of life. And the data on which she bases the definition of social foundations is influenced by the UN Sustainable Development Goals. But at the same time as providing the social foundations of a good quality of life, you have to be within or move back within your ecological ceiling, and the 9 factors that you can see around the outside here defining that ecological ceiling are the 9 planetary boundaries that Johan Rockström, who we were just looking at, and Will Steffen and others identified about 15 years ago. Jason Hickel, an anthropologist who's very important in the degrowth movement, and some ecological economists at the University of Leeds, Dan O'Neill, Andrew Fanning, and others, have in recent years produced a series of studies, not using exactly the same data as Kate Raworth, because they need data which is available on a reasonably consistent basis for 150 countries, for most countries in the world. But they've looked to see whether many economies are actually in the safe and just space of humanity, or whether they're moving towards it over time. And in the chart on the right-hand side, that would mean being in the top left-hand corner of the chart. And as you can see, none of the countries that they discussed in the study that was published a couple of years ago in Nature Sustainability was there. They divided up the sample of countries into 3 groups, really. The countries towards the bottom left, the orange countries that you can see there, they are, for the most part, on a per capita basis, below their ecological ceiling, but they're not providing the social foundations of a good quality of life. The countries in the top right-hand corner, the rich countries, they're providing most of the social foundations, but they are outside, and in most cases, very far outside their ecological ceiling. And then there's the third group of countries, the Brazils and the Mexicos, and those countries, they're outside their ecological ceiling, but at the same time, they're not providing the social foundations of a good quality of life for their people, and they tend to be countries with a very high degree of inequality. In other words, this study is saying there are no developed economies in the world at the moment. There are no economies that are currently in Kate Raworth's ring, the closest to them being Costa Rica, as you can see in the chart. Anyway, yes, there are better measures we ought to be looking at, but although they've caught on with some people, they don't meet my requirements for working with our students and the sort of economic modeling that we want to do in the future, because I want a summary statistic that we can work with, a simple summary statistic that we can compare with real GDP when looking at future scenarios, when thinking about policy options. So let's move on to summary statistics. There is a summary statistic, a summary aggregate statistic of our ecological impact on the planet and the extent to which that is sustainable, which again, you may well be familiar with, and I might have spoken to you about before, published by the Global Footprint Network, which compares the ecological footprint of our economic activity with the biocapacity of our planet, to identify, or to attempt to identify the extent to which we are living within those sustainability precepts that we mentioned a few minutes ago, not drawing down non-renewable resources unsustainably, not using renewable resources at a rate above the rate at which they can be renewed, and not generating more waste than our planet can safely process. And according to the Earth System scientists at the Global Footprint Network, we've been using more than one Earth's worth of resources since about 1970. So for more than 50 years now. And although the chart on the left-hand side isn't entirely up to date, if it was up to date, it would be telling us that we'd be using about 1.75 planets worth of resources a year at the moment. Of course, this is where Earth Overshoot Day, that you might be familiar with, comes from every year. But if we want a measure of the net benefits of economic activity, taking into account the benefits and costs which we can describe as strictly economic or social or environmental, then the best available statistic is the genuine progress indicator pioneered by the great ecological economist Herman Daly and by our own friend Phil Lawn in the last 25 years or so, who's done a number of GPI studies. Now, the genuine progress indicator has a lot of theoretical validity to back it up. It is expressed in dollars the way GDP is, but it takes into account, well, there are good reasons why it doesn't have real GDP and the economic factors influencing well-being, but instead has personal expenditures adjusted for consumer durable spending and inequality and underemployment. And there are good reasons why GPI studies tend to include the social benefits, pluses means benefits and minus means costs, that you can see around the left-hand side here. And there are good reasons for the environmental factors which are included in the approach to the GPI, which this chart refers to, which I've taken from the website of the Donella Meadows Institute. However, any statistic like the genuine progress indicator, first of all, it's going to be very subjective. And for that reason, there isn't one generally applied approach to calculating the genuine progress indicator everywhere around the world. Secondly, because national statistical agencies just don't put their resources into this kind of thing, there are not GPI statistics available conveniently for every country in the world either. And the GPI is very complex to put together. I know that because I've seen down the years Phil doing genuine progress indicator studies and just how long they take and how careful you have to be in putting the statistics together, deciding exactly what you're going to include in order to cover the economic, social, environmental benefits and costs of economic activity the best way you can. That's going to involve some subjective judgment, given that not all studies include the same factors. Secondly, how are you going to weight them? How are you going to value them? So the GPI is a great statistic where it's available, but it's not widely available without the resources of national statistical agencies behind it. It's going to remain not widely available around the world. And it's just too demanding for one person to do this work on his or her own, or even in a small group of people. I saw Phil practically have a nervous breakdown trying to pursue a project involving the calculation of the genuine progress indicator for a large number of countries in a consistent or comparable manner. Now, I did a talk about a simplified version of the GPI at a conference in Poland last year. And even my simplified version of the GPI was very difficult to put together. But what I noticed was that where you're looking at the economic variables here, putting real GDP per capita into an indicator instead of personal expenditure adjusted for issues to do with consumer durables and net capital investment doesn't make a big difference to the answer you get. Income inequality, That's very important in the GPI. It's going to be important in our indicator as well, where we're going to take it into account in exactly the same way that it's taken account of in GPI studies. Now, the great thing about using real GDP data and income inequality data is that they are easily and widely available for almost every country in the world. Also important is data on the costs of unemployment and underemployment. Now, lost leisure time or overemployment is an important issue too, but I've noticed that countries with a high underemployment rate, countries where there are a lot of people who would like more hours of work than they currently have, tend, because they are societies with a great deal of economic insecurity, to be places where a lot of people are overemployed as well. There's a correlation there. It's really important to include evaluation for domestic labour in any study of well-being, as I was mentioning a few minutes ago. But that tends to dominate the social factors in these calculations. As far as environmental factors are concerned, you need a figure for the cost of carbon dioxide equivalent emissions. So we're talking about carbon dioxide, but also methane and nitrous oxide here. But some, at least, of the other environmental costs you can proxy for by using data on a country's material footprint. The material footprint of a country is the biomass, fossil fuels, metal ores, and non-metallic minerals, the tonnage of all those things, which is used right the way along the supply chain in order to produce the goods and services that the country consumes. When you include those things, as I've said, it's correlated to some of these issues which are covered in more complicated, you might say, more theoretically valid GPI studies. And that's what I've tried to do in a much simpler statistic. So we want our own simpler statistic. I want something that we can put together quite quickly. I want something where if I had 2 or 3 months, I could calculate this statistic for every country in the world, pretty much. 150 countries. Anyway, I'm not going to be doing that because I'm ridiculously busy running the hopefully great courses that we're running at the moment. But I can get things started. So that's what we're doing at the moment. We want our own very user-friendly indicator. I want a statistic which I can calculate based on easily available, already published data, because I don't have huge resources behind me, to produce a hugely simplified version of a GPI where I could do 4 or 5 countries in a day easily, but where my Modern Money Lab prosperity indicator, or MPI, if that's what we're going to call it, will give the same sort of result that you'd get from doing a more complicated GPI study. So that's what I'm looking at here. How can we find just 5 or 6 easy to find statistics which will give us something like the genuine progress indicator, if we're not too precious about the theoretical validity of what we're doing? So unlike the GPI, the aim is to construct an indicator which can be calculated in a few minutes for almost any country from easily available data, more or less on the back of an envelope. This involves subjective judgment. It's not designed with theoretical validity in mind. The statistic I'm going to talk about in a moment, you might see as childishly simple, but I think it's going to be a useful first step to fling at our students and say, what do you want to do with this? How might you use it? How might you improve it? So it leads to our MPI, let's call it, which I've sort of justified because I put it together to give me results which are similar to the rather more sophisticated study that I was talking about last year in Poland. So this is what I put together: the Modern Money Lab Prosperity Index. Real or inflation adjusted gross domestic product per capita. Get that from the World Bank. I get GDP data from the World Bank. I get the measure of economy-wide inflation called the GDP deflator from the World Bank. I get population statistics from the World Bank. That allowed me easily to put together a real GDP per person set of data from 2000 to 2003 for as many countries as I want. Then where the cost of inequality is concerned, because I want to take real GDP per capita and I want to deduct, well, three things. But first of all, a figure for the cost of inequality. I'm going to do it essentially the same way they do it in GPI studies. I'm going to do it using Gini statistics I was talking about before. Now, there is a standardized world income inequality database, which I actually used in those charts that we looked at a few minutes ago. There's a world inequality database, which Thomas Piketty and Emmanuel Say's curate. There's also a United Nations World Income Inequality database, and that's what I've used for the sake of putting these statistics together. They differ for a variety of reasons, these different databases that I won't worry about at the moment, but basically we're interested in net income or income after taxes and benefit payments. How unequal is income in a particular country? You need a benchmark, a sort of perfect performance to compare a country to. And I've chosen not perfect equality, I've chosen a degree of inequality in countries like Sweden, Finland, Denmark, and Norway in the early 1970s, which was a Gini statistic of 20. And our cost of inequality in each country's case is going to be how much more unequal are these countries than those Scandinavian countries were when they were at their most equal during the period of modern economic development, which is back in the 1970s. We then need some data on the ecological costs of economic activity. Of course we do. This is vitally important. So I include the costs of carbon dioxide emissions, as well as emissions of nitrous oxide and methane. And I got those directly from our World in Data site, which provides very convenient data here. I have compared for each country their territorial emissions, which depend on productive activity within the country, with their consumption-based emissions, which are an estimate of the emissions generated as a result of what's consumed in the country. So it takes imports into account. And I've included the higher of the two. So in the case of China and Australia, our territorial emissions are higher than our consumption emissions. So we include territorial emissions. In the case of Germany and the US, it's the other way around. So we include consumption emissions. How have I priced these emissions per ton? Well, that's, again, extremely subjective. If you use data from neoclassical studies, you get a very low figure for the cost of a ton of carbon emissions. If you look at work by environmentalists, there are some publications that say that we ought to be pricing a ton of carbon dioxide emissions above $1,000 at the moment. What I've done is I've chosen what I think is a reasonable figure of about $200 per ton for 2023. And then going all the way back down to 2000, I've had between 2000 and 2023 an increase in the price that I've used for carbon dioxide equivalent emissions from year to year, which is inflation plus 5%. This is, you can justify it with respect to some studies that have used this approach, but actually it's quite a conservative approach. You might want to use a higher figure than that. It may be that with the climate crisis approaching, we should be increasing how we cost carbon dioxide emissions more quickly than that. But I didn't want to do anything too controversial. So for the moment, the increase in the price from one year to the next is inflation plus 5%. What that means, given any reasonable assumption about how quickly economies will grow over the next few years, is that the impact of these emissions on our indicator is going to grow relative to everything else over time, so that they are gradually becoming prohibitively expensive. The material footprint data I got from the UN Environment Programme. Now, the CSIRO in Australia will tell you that Australia's material footprint has started to fall in recent years, and they may well be right, but not in our study. And the reason why not in our study is that I've included the material footprint related to what's consumed in a country, but I've also included the material footprint of Australia's exports. And that's the really important, or everybody's exports, but in the case of Australia, that's the really important thing, because the material footprint, for example, of the gas that we are now exporting in far greater value than before, dwarfs the material footprint of our domestic production by the time we get to 2021, 22, 2023. So the CSIRO might say Australia's material footprint is falling. Not in our case, not in volume terms. In terms of valuing the material footprint, I've used a price for a ton of material footprint, which suggests that the growing problem of the excessive amount of biomass, fossil fuels, metal ores, and non-metallic minerals that we're extracting from our environment is about half as big a problem at the moment globally as the impact of carbon dioxide equivalent emissions. I've then got a figure for the cost of unemployment and underemployment. As far as underemployment is concerned, remember you're underemployed if you have some paid employment at the moment, but you would like more hours. Although on average around the world, people that want more hours of work only want about a quarter of a full-time job added on to what they're doing at the moment. I've counted someone who's underemployed as having 50% of the weight of an unemployed person in the statistic, because more underemployment in general means more insecure employment. And what we're really looking at here is the psychological impact of being involuntarily unemployed or underemployed. It's important to include it in the statistics. Of the 5 things that you can see on the screen at the moment, the cost of un or underemployment has the smallest impact on the data. That is because, of course, most people are not individually un or underemployed, at least in countries where there isn't mass unemployment. I then added on, because it's not in the national income accounts, a valuation for unpaid household or caring labour, which it's important to include in a measure of well-being. This is problematic, though, because there are not widely available international statistics. And in those countries where statistics are available, they're not calculated, they're not estimated every year. I mean, when they survey people, when they do time use studies, most countries do not do time use studies every year. So there's a certain amount of, again, subjective judgment, interpolation here. As it says on the left-hand side, the only component which is not easily and quickly available for most countries is this one. But time spent per adult per day doesn't change quickly under normal circumstances from one year to the next. So it is possible to, by making some reasonable assumptions, to overcome this problem. And it is important to include it in your MPI index, although it's not going to explain significant changes in that index from one year to the next. How do we value an hour of unpaid labour? For that matter, how do we value the cost of unemployment? You could use, I suppose, the average wage of people in work, but if you use the arithmetic mean, then that's biased upwards. as an average measure in countries with a high degree of inequality. So I didn't want to do that. You might want to use the median hourly wage, but that's not available from everywhere. So I couldn't use that. So what I ended up doing is taking real GDP per capita and adjusting it for the cost of inequality and getting a shadow yearly wage on that basis. And then just taking 52 weeks a year and assuming a 38-hour working week, getting an hourly shadow wage and sticking that into the statistic to value unpaid household or caring labour, and also using this approach to value the cost of unemployment in the statistics too. You could value household labour by identifying the activities that people do in households and applying market wage rates to those various activities. And sometimes this is done. It's simpler and more realistic in a study like this one, just to take the estimated number of hours a day that people over the age of 15 put into a household and caring labour and use that in the statistic, which is what I've done. You end up with a figure which is maybe 20, 30%, sometimes a bit more than 30% of GDP, which is perhaps a little bit on the low side, but at least we've included a valuation of some kind in our indicator. If you do this for Australia, well, you can see Australia's real GDP per person, per capita, as the orange line along the top of this chart. It doesn't look exactly like the line earlier on. I mean, it's at 2000 rather than 2023 prices, but that's just going to influence the numbers on the left-hand side. It doesn't look exactly the same because it's GDP per person here. And of course, Australia's had a lot of net inward migration, including me in the year 2000. So population growth over these years. So GDP per capita doesn't go up as quickly as real GDP. But the more interesting thing for me, and this is exactly what I got in my GPI study that I talked about in Poland last year, is there's been no significant progress in terms of our MPI per capita, our Modern Money Lab progress indicator, as far as Australia is concerned. And why is that? Well, Australia has made no significant progress as far as carbon dioxide emissions are concerned. When people talk about Australia's carbon dioxide emissions falling since 2005, that is entirely based on land use change in forestry data, which we've excluded here, which you can say is picked up sort of in our material footprint statistic, and where the accounting for it is seen by many people as pretty dodgy anyway. We are promised that Australia's gross carbon dioxide emissions will fall quickly in the next few years as we approach 2030, but it hasn't happened yet. Australia has had essentially no reduction in its carbon dioxide emissions over the last 20 or 25 years. And that's why you can see the blue line on the left here, which is emissions costs per capita, rising over time. And that's, as I said, carbon dioxide, methane, nitrous oxide, so it's CO2 equivalent emissions per person, valued. As I said, we were valuing them, so the real cost is increasing over time, so the emissions cost per capita is increasing over time. Of course it should do, because this is becoming more and more of an issue as it's more and more vital for us to significantly cut our emissions. Our gross emissions need to fall by 80 or 85% if our net emissions are going to fall towards zero by 2050. Of course they do. And our extraction cost per capita has increased rapidly, particularly in recent years. And that is particularly driven by not just the price going up, but also the increase in iron ore production and liquefied natural gas production increasing our material footprint the way I've defined it. Australia's income inequality has yo-yoed up and down a little, but hasn't changed very much since the year 2000. There was a very major increase in inequality in Australia in the late 1970s when we gave up on full employment, which continued across the 1980s and for much of the 1990s as well. And there isn't time this evening to do lots of analysis of our MPI, but I just thought it'd be interesting to see what would happen if nothing else changed. And if, using my statistic, if we were to imagine the degree of inequality in Australia returning from a Gini statistic of 34 point something down to about 26, which is where we were at the beginning of the 1970s. And you can see that our measure of sustainable prosperity increases hugely, which is kind of interesting. You can imagine, if you're a degrowther, you can imagine that in the future, we may have to give up on real GDP growth. Real GDP per capita might fall. Well, it's possible to imagine real GDP per capita falling while our Modern Money Lab prosperity indicator increases, if we imagine ourselves in a community with a much lower degree of inequality of net incomes. And of course, you can do other things as well. You can explore scenarios, realistic scenarios, hopefully, about carbon dioxide emissions or material footprint. What about the US? Well, the US looks as though, at least since about 2014, it's done a little bit better than Australia, at least in terms of the trend, the movement of the trend over time, when we look at the MPI data. And this is because the US had very high unemployment around about the global financial crisis and immediately afterwards, and unemployment gradually fell back. So the cost of unemployment in the US fell as we approached the pandemic. We then had a spike during the pandemic, of course, which has been reversed again now. But it's also the case, well, in Australia, the carbon dioxide emissions figure that we were talking about was territorial. In the US, it makes sense to use a consumption-based approach. If you look at America's territorial emissions, people often boast about this in the US because they've fallen quite significantly. But that's because, of course, they've exported their carbon dioxide emissions, but by importing goods and services produced and generating carbon dioxide emissions abroad. If you look at the US's consumption emissions, however, they have fallen, not very much, a tiny bit. So the US looks a tiny bit better recently than Australia. What about if we took American inequality and returned it to its low point? Well, in the case of America, America in modern decades has always been a highly unequal society in terms of net income, but it wasn't as unequal in 1980 as it is now. And you can see that if we were to return 2023 to a 1980 degree of inequality, other things remaining equal, our MPI statistic for the US, instead of trending down a little bit, would jump upwards for what it's worth. And again, you can do other things with these statistics. Of course you can. What about Germany? In the case of Germany, you can see our indicator was falling as we approached the global financial crisis, has increased significantly since. You can see that the gap between real GDP and the Modern Money Lab prosperity indicator was very narrow in the early 2000s. Well, Germany, amongst the other countries we're looking at here, has a low degree of net income inequality. It has a redistributed tax and welfare system. This was even more the case in the early 2000s than is the case now. That's why you can see the gap between these two lines growing over time. But in the case of Germany, as with the US, they had relatively high unemployment at the time of the global financial crisis. The German unemployment and underemployment rate has fallen down the years, so the cost of unemployment and underemployment has fallen. And in Germany, consumption, carbon dioxide emissions, and the same thing is true of material footprint, has fallen down the years too. Even as the economy's grown, there's been some very minor absolute decoupling in Germany, which is not the case in Australia, which is picked up in our MPI statistic. Let's do the opposite experiment with inequality in Germany, because inequality in Germany in the last couple of decades, it increased a little bit, and then it's fallen back a little bit. Again, that's not so interesting to look at here, but what I thought I'd do is I'd say what would happen to our statistic if we left everything else the same in Germany, but we injected into the statistics in 2023 in Germany the US level of net income inequality. And we get a dramatic fall in our measure of well-being, which is not surprising, really. What about China? China has had, of course, unprecedented growth, and that growth in real GDP has, to an extent, been reflected in our prosperity indicator. And of course it should do, because it's lifted millions of people out of poverty. But of course, it's been associated with a big increase in ecological costs. Even though China is investing more than everybody else in renewables, the Chinese economy has grown so quickly, of course, that while there's been relative decoupling, there's been no absolute decoupling in China. So the material footprint of the Chinese economy and the emissions of the Chinese economy are, of course, still rising rapidly, not as rapidly as real GDP. In the case of China, income inequality since about the year 2000 hasn't changed very much, but there was a massive increase in inequality during the big years of reform in China in the late 1980s and 1990s. So China is an even more unequal society in terms of net income than the US is. So I decided to do another little experiment here. It's a ridiculous one to do, and it creates a result which is a fluke. It's not something that I set up. But let's suppose we could somehow take the statistics for China and inject a Scandinavian level of inequality in the 1970s into China. According to our indicator, you would get a massive improvement in well-being if you imagined that this was possible. Now, of course, it isn't possible, but what it's reminding us of is that inequality, as we said right at the beginning, matters as far as well-being is concerned, and it's not taken into account at all when we're looking at real GDP. What about the whole world? What about the human residents anyway? Not all the residents, but the human residents of planet Earth. How are they doing as far as our MPI statistic is concerned? Now, for real GDP for the world, I have assessed it at constant US dollar prices again, but I've done something else too. I've used market exchange rates here, and you could argue that I perhaps shouldn't have done that because market exchange rates don't determine what people could actually buy in their local economies. But I decided to do this partly for convenience and also partly because the incredible strength of the US dollar since 2014. And I've seen people talking about how scared the US should be because China is reducing the proportion of its official reserves it holds in the US dollars in recent years. These people have not been looking at the foreign exchange market. The US dollar has been for 10 years really on an upswing as far as its trade weighted index is concerned. And that is reflected in the data I've got here for global real GDP per capita because I'm using market exchange rates. So you can see real GDP per capita for the whole world rising here until about 2011 or so after the GFC, but then going horizontally or even falling slightly. That reflects the fact that the world economy didn't grow as fast after the GFC as before. It continues to reflect population growth, although global population growth is slowing down. It's less than 1% per annum now. But it also reflects, as I've said, the strength of the US dollar. Now, why did I leave that in the statistics? That's because more than half the countries in the world have a problem either with US dollar denominated debt, which is harder to service when the US dollar gets stronger on the foreign exchange market, or with the fact that they are dependent, and particularly people in lower socioeconomic groups are often disproportionately dependent on imported necessities, food or energy, which are priced in US dollars. And this makes it more difficult to develop low and middle income economies when the US dollar is strong, as it's been in recent years. So I make no apology for these real GDP figures being converted into US dollars at market exchange rates. That's basically global gross domestic product adjusted for inflation divided by the world population. When we look at our modern money lab prosperity indicator, it's falling over the last 10 years or so. And one of the reasons for that is what's happening to the real GDP figures. But another reason for that is that the world as a whole is not yet enjoying absolute decoupling, either in terms of carbon dioxide emissions or in terms of material footprint. Indeed, in terms of material footprint, there's hardly any relative decoupling either. As the global economy grows, we continue to increase the biomass, fossil fuels, metal oils, and non-metallic minerals that we extract. So we continue to eat into our natural capital. We continue to take land away from biodiversity. We continue to eat into forests around the world, etc., etc. And that ought to be reflected in a prosperity indicator. And it's reflected in this one. The Modern Money Lab prosperity indicator for the whole world has been falling for the last decade or so. Per capita ecological costs continue to rise. As I said, I priced material footprint so that it's about half the problem of emissions at the moment in our statistic. That's how I scaled it. And you can see world material footprint is over there on the right-hand side towards the bottom, this time in terms of tons from the UN Environment Programme data. And you can see we've got carbon dioxide emissions and the CO2 equivalent emissions. That's where we've added methane and nitrous oxide in as well. They continue to rise apart from where there is a recession or a pandemic. It's important to include this in any statistic which you're going to use if you're trying to indicate genuine progress towards a global economy which provides people with a good quality of life, but at the same time is ecologically sustainable. So it's alarm bells for planet Earth as far as our indicator is concerning. We need to turn that indicator up, and we need to do it for the right reasons. But let's play the silly game again. As far as the degree of income inequality around the world is concerned, global income is about as unequal as it is within the least equal economies. So world inequality is about the same thing as South Africa's net income inequality. So there's a huge cost of inequality when it comes to adjusting real GDP per person around the world in order to get our modern money lab prosperity indicator. And what I've done is I've imagined, and of course this is just ridiculous, but I've imagined, what if net income around the whole world was about as evenly distributed as it was in the Scandinavian countries back in the 1970s? And of course, if you could do that without changing anything else, then that change itself would massively improve our prosperity indicator. It would do nothing at all to real GDP per capita, at least not directly, not except in terms of the effect that it would have on the scale of economic activity around the world. Inequality is not built in to real GDP. Again, it just suggests that as well as concentrating on rapidly reducing our carbon dioxide emissions, in the short run, it's difficult to do that without having an even bigger material footprint, but you need to balance those things off against each other. And they're reflected in our indicator. How they're reflected is entirely subjective. That's why I'm going to be flinging this statistic at our students, saying, can you come up with a better way of producing a statistic which is equally simple as the one that I've started you off with here, the version 1.0. But it suggests that not just emissions, but also inequality are things that we ought to be focusing on. And we could have a higher level of well-being around the world, even if there was a smaller global economy in the decades to come, if we had the right infrastructure for a post-growth economy with a focus on well-being in place. So that's it, really. What next? We'll aim to produce a statistic as simple as this one. I don't want it to become more complicated, but I do want to question the back of an envelope assumptions on which it's based for every country in the world, if we can. And we'll update it along with the other data we've already put on the Modern Money Lab site, so other people can discuss improving it. But that's the only thing I'm going to insist on. It's got to remain simple. And apart from what I said about household labor, I want the statistics to be easily available for every country, or for almost every country in the world. And then we can use it as a basis for discussing scenarios, including sufficiency and the whole degrowth issue. We can develop realistic but simplified stock flow consistent macroeconomic models, which we can integrate with something like a prosperity indicator like this one, which I hope some of our students are going to help with, and maybe you might become one of our students. If you do, then you'll be on the graduate program in the economics of sustainability, which Modern Money Lab offers in partnership with Torrens University, Australia, and which starts in, well, it starts in a couple of weeks, but we start in June and September and February every year. So join us if you can. And for what it's worth, that's what I was going to talk about this evening.